This video is designed to help you work through the first example in our probability flip chart. So this one, we're given some data about students in a class and their musicality, what instrument they play. So some of them play the piano, some play the guitar, and some play both. It's possible also that some don't play either of those instruments. So what we need to do is to calculate probabilities of certain events happening. And an easy way to do that is to try and present this data using a model that helps us to do that. So probably the easiest model to use to solve this kind of probability question is a Venn diagram. So with a Venn diagram, when we're given information about 2 or 3 different things, sometimes the Venn diagram is the easiest way to present that data in an easy to understand way. So in this case, we've got a class of 24 students. 12 play piano, 10 play guitar, and 3 play both piano and guitar. So the easiest way, when we're doing some sort of a problem like this one, the easiest way is to draw ourselves a little blank Venn diagram, like so. And the number of students total in the class is 24. So the sample space, the entire population of students that we're talking about, is 24. So eventually, when we've got all of our little segments of this diagram filled in, all our numbers need to total up to 24. Okay, so the easiest place to start with a question like this is the intersection part of this Venn diagram. So the bit that represents the students that play both piano and guitar. So we might label our little circles here, piano and guitar. So the little bit of the Venn diagram that overlaps in the middle is the students that play both the guitar and the piano. So we know there that we've got 3 students that play both instruments. Now we can go back to the other information that's there. So 12 students play the piano. So what that really means on our Venn diagram is that this entire circle that represents the students playing the piano needs to total up to 12 students. So we already have 3 students in that circle, which leaves 9 extra students that play only the piano. So we've got 9 that play only piano and 3 that play piano and guitar. So total piano students totals to 12. In the same way, the circle that represents, I'll just do that in a slightly different colour, the circle that represents guitar students needs to total 10. Okay, and again, we already have 3 students that play guitar. They just happen to play piano as well. So if I already have 3 students that play the guitar, and I need a total for that circle of 10 playing the guitar, it means 7 students play guitar only. So now I'm almost to the end of my diagram. I've almost covered everything except for the section which lies outside of the guitar and piano circles. So, and that represents the students who don't play either of those 2 instruments. So my total amount of students in that class was 24. At the moment, I have a total of 7 plus 3 plus 9, which is 19 students, and I need that to total to 24. So I haven't used all of the students in the class yet, which would indicate there are some students that lie outside of those 2 circles who do not play either of those 2 instruments. So if I have a total of 24, I've already used up 19 of those students. I have an extra 5 out here that don't play guitar or piano. So then if I do a quick double check before I keep moving now into my probabilities and total all of the students now, 7 plus 3 plus 9 plus 5, total 24. So now I'm happy that my diagram actually reflects the information in the question. And now I can move on to answering the probabilities. So the questions ask me now to calculate the probability that a student randomly selected from this class plays the piano only. So the people that play piano only, there's 9 students out of a class of 24. Probability of a student playing piano, 9 out of 24. And you would need to give your answer in its simplest fraction form there. So 9 out of 24, I know that's going to cancel down to a fraction lower than the form that it's in there at the moment. 3 goes into both of these numbers. 3 goes into 9 3 times, and 3 goes into 24 8 times. So the probability of a student out of that class picked at random who plays only the piano is 3/8. Okay. In a similar way, the probability that the student plays the piano and plays the guitar. Okay, this section in here, they play the piano and the guitar. Okay, that little intersection part of the diagram. So the probability that a student plays piano and plays guitar would be 3 out of 24. And again, that would simplify down to 1 out of 8, 1/8. If we're talking about probability that a student plays the piano or the guitar, that could include these students that play piano, these students that play guitar, or also those students in the middle. So it's basically any student that plays any of those instruments. So we've got a probability there of 19 out of 25. So they could play the piano or the guitar or both. Okay, they're all included in that question. And then our final one is just the probability that the student does not play the piano. So the only ones that we are interested in here, these students don't play either. And these students here don't play the piano. So these ones do, and so do these ones. So we're not interested in those, but we're only interested in the ones who do not play the piano. So the students that do not play the piano there, 7 plus 5 would be 12. Oh, out of 24. I just spotted a little error there that I made in the one before. Not 25, it's out of 24. Okay, so 12 out of 24 will also obviously cancel down to a half.